Welcome to lesson 4.1. So we are starting our unit on systems of equations. So first and foremost, we're going to kind of talk about labeling systems, and then we're going to start with graphing, and we'll look at the graphs. So when we're labeling systems of equations, so the systems of equations just quite literally means two or more equations. So it makes a system. We have graphed linear equations, just one. And so now we're working into systems, so two. And we get to determine certain things about them when that happens. So, for example, when we say a system of equation is consistent, that means there is a solution. Okay, so again, if we say if there is a solution, that means that it is consistent. Okay, that means for a graph that the two lines will intersect. They hit an ordered pair. If it's inconsistent, that means no solution. Okay, so again, consistent means there is a solution. Inconsistent means no solution. Now, within it being consistent, so we have determined there is a solution for the system of equations. There's two different ways we can label this, and it depends on what type of solution. We have independent and dependent. So think about independent means there is one solution. That means that the lines just intersect at one spot. They don't cross multiple times. It's quite literally they hit at one spot. That is their solution. So if it has a solution and it has one solution, we would label the system consistent independent. Okay? If it's consistent dependent, that means that there is infinitely many solutions. And then an inconsistent system can't be independent or dependent because it doesn't have a solution, okay? So again, if it's independent, it has one solution. If it's dependent, it has infinitely many solutions. If it's consistent, there is a solution. If it's inconsistent, there is not a solution. So now we're going to kind of talk about what that looks like on the graphs and what that means for us, okay? There's three different methods to solving systems of equations. There's graphing, substitution, and elimination, but we're going to start with graphing, okay? So let's open up the foldable. So I have the two equations. So I have y equals 2x minus 1 and y equals negative 3. Those are two lines. That is, this right here is a system of equations, okay? There's two lines. Now, we're going to graph both of them and see how we can label this. So I'm going to color code. So this first equation is going to be green. The second one is going to be blue, okay? So we graph them just how we normally would. So y equals 2x minus 1. The y-intercept is negative 1. My slope is 2, so I'm going to go up 2 to the right 1. Or down 2 into the left 1, and draw my line. Okay, it is important for these. You have to cover the whole graph, because if you don't, you may miss where the lines intersect, okay? So please make sure you're paying attention, okay? And then we have y is equal to negative 3. So negative 3 is right here, and that is going to be a horizontal line. Okay, so now let's look at these lines. The lines are intersecting. Okay, where they intersect is the solution to the system of equations. So this system would be considered consistent because there is a solution, and independent because there's one place that the lines intersect, and it's only that spot the lines would intersect. So the solution to this system of equations is the ordered pair -1, -3. And if you look, that is right here, okay? That is where they intersect, okay? So where they intersect, right here, that is your solution, okay? So where the lines intersect, that is your solution. So if they only intersect once, it's considered consistent because there is a solution, and independent because it is one solution. Okay, so now let's go over to the one right next to it, y equals x plus 1 and y equals -x minus 3. So again, I'm going to label blue and green. So y equals x plus 1, 1 is my y-intercept, my slope is 1 over 1. So I'm going to go up 1 to the right 1, or down 1 into the left 1. Again, you don't have to draw this many lines if you don't want to, but you do need to cover the whole graph and make sure it is accurate, so it needs to be straight. And then y equals -x minus 3, so minus 3. And then I'm going down 1 to the left 1, or down 1 to the right 1, excuse me. Down 1 to the right 1, or up 1 into the left 1. Okay, and so then I'm going to draw my line. And if you notice, these lines are intersecting. And then where they intersect is your solution. So that point is -2, -1. So my solution to this system of equations is -2, -1. It's the whole ordered pair. That means that this system is consistent and independent. There is a solution, consistent. There is one solution, independent. Okay, so now let's go to the next two. Y equals 2x minus 1, and 2x minus y equals 1. Okay, so we're going to graph these. Now, remember that if you have standard form, you can do one of two things. You can graph it in standard form, or you can rearrange it. It doesn't matter. It's kind of up to you. So blue, green. So y is 2x minus 1. -1, up 2 to the right 1, up 2 to the right 1, down 2 to the left 1. So that's that line, 2x minus 1. Okay, now I have this other line, 2x minus y equals 1. Now, is this one going to be super helpful to graph in standard form? Not necessarily. You can. If you did, it would be 2x equals 1. And -y equals 1. So x is 1/2 and y is -1. Or you could rearrange it, and when we do that, this equation is y equals 2x minus 1. And if you notice, it's the exact same line as the first equation. But if you were going to graph it, y is -1, and then your standard form y is 1/2, and you notice these lines are the same. Okay, these lines are the same. And when that happens, it's the exact same line, it's just rewritten in two different ways. That means this system of equations is consistent and dependent. Okay, so if the lines are on top of each other, they're the exact same line. That means it's consistent and dependent. And that means that the solution to this system is infinitely many. Because if you really think about it, the line is constant. These two lines are constantly intersecting. So the whole line is a solution. Okay, so that means forever and ever and ever, they're always going to intersect. Okay, so now let's go to the next one. So I have green and I have blue. This one in standard form, I'm going to rearrange, and if I do that, I'm going to subtract 2x, so then that's y equals -2x plus 5, and if you notice, they're the same line, but if you didn't, that's okay. So 1, 2, 3, 4, 5, and then down to okay. And so I draw the line, draw the line. And then if I graph my second line, y is 5, and then down 2 to the right 1, down 2 to the right 1, you notice it ends up being the exact same line. So the lines are the same. And since they are the same, that means it's consistent because there is a solution, and dependent because there's infinitely many. It's always intersecting because they're the same line, so that means there's infinite solutions, okay? And then the last section, we have y equals 2x minus 1 and y equals 2x plus 1. Now, if you notice, they both have the same slope, right? And if we recall back in unit 3 with lesson 3.1, if two lines have the same slope, then they are parallel, and that means they're never going to intersect. So if you think about that, they're never going to touch. So that means there's not going to be a solution to this. But let's kind of look at that. So y equals 2x minus 1, negative 1. Then I'm going to go up 2 to the right 1, up 2 to the right 1, or down 2 and to the left 1. I'm going to draw my line. So that's my green line. And now let's graph our blue line. Y is 1, or your y-intercept, and you're going up 2 to the right 1 and down 2 to the right 1. And if you notice, these lines are parallel, so they are never going to touch. They are never going to intersect. And if they never intersect, that means that there is no solution. So there is no solution. There's none. They can't have a solution if they never intersect. Okay, and then now we can look at these two equations. So we're going to rearrange those. So that would be y equals negative 3x plus 4. So it's going to be blue. And then green. And if I rearrange that one, it's y equals negative 3x minus 2. So they have the same slope. That means these lines are parallel. And if you don't notice that, that's okay, because you can still graph them and you're going to see the same thing. So I'm going to go to 4. And then my slope is negative 3, so I'm going to go down 3 to the right 1. Okay, and draw my line. And then I'm going to graph my green equation, so it's negative 2, and I'm going to go down 3 to the right 1, or up 3, and to the left 1. You notice these lines run right beside each other. They're parallel. They are never going to intersect, so that means there is no solution. So we would label this system as inconsistent. It is completely inconsistent, and there is no solution to this system. So that's it for lesson 4.1. Bye.